Hello everyone, welcome back to JDCodebase. Today we are starting one of the most important topic in the data structure and algorithm, that is a time complexity. If you are beginner, don't worry at all. I was also confused when I first heard term like big of O, big of N, big of log N. They sound scary, but actually they are very simple. In this video, we will understand what time complexity really means, why it matters, and how to calculate it step by step. What are the terms like big of 1, big of n square, and big of log n. And in last, why binary search is the big of log n. So by the end of this video, you will not just memorize big of n or big of n square. You will understand how to think it. So let's start it. Now, first question, why do we even care about the time complexity? In real life, data can be very large. If your app handles 10 users, everything feels fast. But what if it handles 1 million users? Slow code becomes a problem. Also, in interviews, companies don't just check is if your code works or not. They check if your code is efficient or not. And correct code is not enough. It must be fast and scalable. Now, what is the time complexity? Time complexity does not measure the seconds or milliseconds. It measures how the number of operation grows when input size grows. An important question to ask is that if input size double, how much extra work happen in this? So that growth is what we measure. So this is the time chart. So means we see the big of n square, big of n, big of log n, big of 1. And so let's start with the big of 1 first. Big of 1 is the constant time. It means the work does not depend on the input size. Like I have an array, let ARR 10, 20 and 30. I want to find the at index 0, what is that element, or at the fifth index, what is the element. So here I'm accessing the first element of the array here. So if array has 3 elements, it takes 1 step. If the array has 1000 elements, it still takes 1 step. So the number of operation does not change here. That is why this is a big of 1 time complexity, a constant time. Next one is the big of n. Big of n means a linear time. Work grows directly with the input size, means as the n size increase, the time is increased. So here the example, if you see here, for a simple for loop, let I equal to 0, I smaller than n, I plus plus, and console.log I. So this loop run 0 to n. If n value is the 5, loop runs 5 times. If n value is the 100, loop runs 100 times. If n is doubles, operation doubles. That is called the linear growth. So this is the big of n. Now next one is the big of n square. Big of n square usually happens when we use the nested loops, and in this growth increases very fast, means dynamically. So if you see here the example, there is 2 for loop nested loops. One is the outer for let I equal to 0, I smaller than n, I plus plus. Second one is the let j equal to 0, j is smaller than n, and j plus plus. And we are console the value of I and j. So this is a normal for loop, these 2 nested for loops. So outer loop run n times, inner loop run also run n times. For each outer loop, inner loop runs n times. So total operation here becomes the n cross n square, means big of n square. If n is the 10, then 100 operation. If n is 100, then it's becomes 10,000. Let me show you in the VS Code. Here I just write for let I equal to 0, I smaller than let's say n, and I plus plus, not the navigator, I plus plus. And for let j equal to 0, j is smaller than n, and j plus plus, and console.log I comma j. And here I am initializing the value of let n equal to 5. So let's run the code. Node 01 the file name, and I get the here for the 0 I get 1 2 3 4, and every time the inner loop value come again 0 1 2 3 4 5. For that counting, let's count equal to 0, and here count plus plus. Let's see how much time it's run. Console.log count, and let's run. Means for n is equal to 5, it runs 5 times 25 times. If it is 10, then it runs 100 times. If it I becomes it makes the 100, then it runs till the 10,000. See how dynamically it grows. So this is called the big of n square quadratic time. That is why big of n square is dangerous for the large input. Now next come to the big of log n. Big of log n happens when we reduce the problem size every step. Best example for this is the binary search. Like I will show you in the next upcoming slides this binary search this. Now how loops affect the complexity. These means a single loop runs big of n. If nested loops runs big of n square. If this sequential loops runs means if single for loop, then a single for loop, not the nested one, just a different new one, new for loop here, new for loop there, and so two separate loops one after another, so their complexity becomes big of n plus n, and so after that big of 2n. But in the big of notation we ignore the constant, like this variable 2 3 4 it does not matter here. So big of 2n becomes the big of n. So we keep the dominant term only here, means like here, and if there is n square we take the n square here. Now ignoring the constant, I already tell you we ignore the constant, like in the big of 2n I just write big of n, and a big of n plus 10 we just take big of n. If in the case of big of n square plus n we take the n square. We keep only the dominant term and always keep the highest growing term in the time complexity. Now see, these are some these examples for the printing array. Means you have to analyze the as the time complexity for this. Like I have an array function print array. It takes an array as a parameter here, arr, and inside this we are running a for loop. I is equal to 0, I smaller than arr dot length, I plus plus console.log arr of 5. Means if arr dot length becomes the, this loop runs from 0 to arr dot length, and if the array size is n, it runs the n times. So no special in this. So time complexity is the big of 1, a simple for loop. Next one is the nested loop. Inside this I already show you here how dynamically it's changed by, means if 100 is there, then 10,000, for 10 it's become 100. So this is just a, for nested loop just use the big of n square. And I already show you the why big of n square is dangerous. For 10 it shows the 100 operation, for 100 it shows the 10,000, for 1000 it shows 10 lakh. So growth is very fast, many means dynamically grows. Now example 3 is binary search. This is the most important and most optimal time complexity. In this case big of log n, means we are divide the array into parts. Means let's see, if you see here, let's see here I have the, so if you see if you able to see, I just declared two variables, left and right. First one is the 0th index, second one is the array dot length minus 1 last index, and every time I just check the middle element. If the middle the target is in the left right or the right side, so we just ignore that part. Means if arr mid if the smaller than target, we just ignore the left part. If it is greater, we just ignore the right part. Means every time the it's half the array. Means for if array size is 16, first half is 8, then 4, then 2, then 1, and each step half the array means half the problem. So this is a logarithmic time complexity big of log n. So why binary search is powerful? Because it reduces the step here, not the increases like the big of n square. So quick comparison here is the big of 1 is the best because we are just get the instant value, and big of n is very efficient. Like in the binary search we see big of n is acceptable but not very like big of log n, and big of n square is expensive. We have to optimize this compulsory. This big of n square means as the n increase, n square grows much faster than the n. So these are some the problems, so you have to solve it by yourself and comment down these answer means what is the time complexity of this. Like here it runs a simple for loop from 0 to n, and so its time complexity is the n. Next you have to solve this and also comment down the time complexity for this second, third, fourth and fifth. So let's summarize these. Today we learn what time complexity is, why it matters, difference between the big of n, big of 1, big of n square, big of log n, how to analyze the loops, why constants are ignored, and why binary search is the powerful. So if you understand this topic clearly, you have built the foundation of the DSA. Now time complexity is about not about memorizing formulas, it is about thinking. If input grows, how does work grows? From today, whenever you write a loop, ask yourself, what is the time complexity of this code? That habit will make you a strong developer. It's not matter whether you are a one stack or a pan stack or you are using Python or JavaScript. The time complexity is for everyone. Means if your code is not suitable for the larger input, it's a bug. So if this video helped you understand clearly, like the video, subscribe to JDCodebase, and in the next video we will go deeper into the problem solving. Thanks for watching. I will see you in the next video.